Okay, so today's webinar is about moving from SOLIDWORKS to Onshape. I'm going to take a look at a few top tips and best practices. I know a lot of people are moving to Onshape, and it's not necessarily just from SOLIDWORKS. It could also be from Creo, CATIA, NX, Inventor, Solid Edge. Any of the popular mainstream mechanical CAD systems. The process of moving from one system to another is fairly similar, and Onshape handles the data from all those different CAD systems in a very similar fashion. So during this webinar, we're going to, if you have got any questions, please type them into the GoToWebinar question panel. You can also contact me before, during, or after the webinar using the email address, the Twitter handle, and also there's my forum address. If you go on the forum, I'm usually there most days. If you've got a technical question, it's by far the best place to go. Of course, you do need an Onshape account to go on the forum, but it's worthwhile. There's a lot of very enthusiastic users on the forum who help people daily. Okay, let's move on. Like I mentioned, enter any questions into the GoToWebinar panel. For today, the agenda is really we'll start off at looking at what are the similarities and the differences between the two systems on SolidWorks and Onshape. What the features are the same, what features are different, and really what are the benefits and why people are moving to Onshape, or indeed running Onshape alongside their existing CAD system. Now, as people have a CAD system, most people do have a 3D CAD system, then there is a lot of legacy data. So we'll take a look at how it can be transferred, how to reuse it, and how to modify it if you need to. You've got an old design, you want to reuse it, or you want to do some slight tweaks to it, then we'll take a look at certain ways of doing that. Then we'll take a look at setting up the user interface in Onshape. So there are, like I said, there are a lot of similarities between the two systems, and you can make it even easier by setting up mouse settings and also the S key, which you might be familiar with if you're a SolidWorks user. And then finally, the areas I want to touch on in this webinar is to look at some of the fundamental differences. Now, there are some online training videos that you can watch. There are self-paced. There's also questionnaires and exercises, and those can be found at learn.onshape.com. Now, all those are free, so even if you are not a Onshape professional user, which gives you access to more data or more lessons, I should say, even if you're a free user, you can still get access to those videos, so they're worthwhile looking at. But really what I'm going to look at here is to just briefly cover the difference between a part studio in Onshape and a regular part in SolidWorks, how we do assembly makes difference, and also how we share data. And these are probably the three big areas where new users coming from another CAD system might stumble in Onshape. So it's a very useful looking at these particular areas. All right, let's kick on. So the similarities between the two CAD systems, they are both professional mainstream CAD systems that are used by thousands of companies around the world. They both cover the basics of parts, assemblies, and drawings, and they are parametric, feature-based, and associative. Parametric meaning you can define your models with parameters or dimensions. The feature-based in that you have things like holes and fillets and chamfers, and also associative. So if you make a change in one place, the change propagates through to all the other places. It propagates through to the assembly, it propagates through to the drawing, and anywhere those parts have been used as well. Now, SolidWorks, Onshape, and many other parametric, feature-based, and associative CAD systems all have a familiar design workflow. And if you've never used Onshape before, but you have used another CAD system, you'll find that you can pick it up fairly easily. The layout of the user interface is very similar. How you interact with a model is very similar. But of course, there's going to be some slight differences. And again, we'll look at that later. And from a SolidWorks standpoint, the big thing, which is the similarities between the two systems is they are both based on Parasolid and D-Cube technology from Siemens PLM. So back in the background, they have the same engine, but really in the foreground and how these products are put together and how they are implemented and how the end user sees them, this is where the differences are. But underneath it all, they are both run by the same engine. So on many levels, that gives a lot of compatibility between the two systems. Transferring data is very easy between the two because there is very rarely any kind of geometry issues related to transferring data from one to the other. Because there's a reason why there's a familiar design workflow, and that is because it's the same founding team which created Onshape, which also created SolidWorks, the likes of John Hirschtick and John McElhaney and Scott Harris and Dave Corcoran and all these guys who set up SolidWorks originally back in 1995. They are also the founders of Onshape. So they've got lots and years and decades of experience in building CAD systems. Okay, now if you go on the onshape.com website, there are some pages doing some comparisons at a feature level, or sort of a high level feature level, between the two systems to give you an idea about what is available in both and what is a common between the two, but also what is the difference. And you'll see, I'm not going to go through these in every single detail, but down at the bottom there, it's talking about advanced mold design, weldments, wire pipe and tube routing, which is an additional package if you buy SolidWorks Premium. These are the things that SolidWorks has that Onshape doesn't. So there are going to be some companies who who are not able to fully embrace Onshape because it might not have the capabilities there yet. Of course, we do an update every 3 weeks. So new enhancements and improvements are coming at a very rapid rate. So that's from part modeling. From an assembly modeling standpoint, we have assembly mates and limits and relations. We do them slightly differently. But then also things like interference and collision detection. We do it at the we do it differently. So we can take a look at that. And then also from a drawing level, we can see there's a lot of similarities there. We don't do automated exploded views. Again, that's something that will come eventually. And whole tables, weld tables, cut lists, kind of makes sense because we don't do fully blown weldments yet. However, we do have the opportunity to create custom features, and there is a custom feature called Beams, which basically creates a similar environment to weldments in SolidWorks. And finally, there is an option there at the bottom there for model-based definition. Really, that should be in the part list, not under drawings. But again, that is some capability which is an add-on for SolidWorks at cost, of course. Okay, so from this, just briefly looking at them, we can see a lot of similarities. Now, why would a company go from one CAD system to another if they're pretty much the same? And in fact, you could argue that Onshape has less capability because there's other things like cable routing, model-based definition that it doesn't do just yet. Okay, but one of the main differences why people go to Onshape is that because it is fully cloud-based, there is no local install on your machine. So there's never any downloads, no installs or service packs. Now, this is something which can take some companies hours, days, even a whole weekend, depending on the number of users they've got to actually install service packs and make sure that everyone's on the same version. So there's no version conflicts or file incompatibilities because everything is done at our end on the server side. So everybody is always on the latest version of Onshape at all times. So there's never any version conflicts, and Onshape doesn't use files, so there are no file incompatibilities. So there are no files. Everything is based on a database, so you can't lose or corrupt files. Okay, and there's no crashes or data loss. Now, that's a very bold claim about no crashes. In reality, things like Parasolid and D-Cubed crash. It's just that Onshape handles it very gracefully. And because everything is based on a database, every time you do an action, it is recorded. So if something were to happen, the power to go down or your computer crashed, you'd only ever lose, at worst, your very last edit. Whereas, of course, in a desktop install environments, not picking out SolidWorks in particular, because all CAD systems do it because they're very complex software, they crash. And unless you are saving regularly, you're going to lose a lot of data. There's no license keys to manage in Onshape. It's all if you have to deploy CAD to new users or even to different sites, you don't have to worry about expensive hardware. You don't have to worry about getting license keys from your reseller or installing it, shipping hardware out to users. All they need is you just add their name, their email address to your list of users. Within seconds, they're up and running. So again, another advantage. There's no PDM required. So, there's a lot of companies who do use SolidWorks and other products without PDM, which is probably asking for trouble. But all the data management capabilities, including workflows and release procedures, is all built into Onshape. Finally, because there are no files, there's no need to do things like email or FTP or Dropbox files to other users, either inside your own company or externally to suppliers as well. So that means there is no IP security issues because your data stays on our servers at all times. Okay, so that's just a quick overview between the two systems. I've got a couple of questions here. A note saying the assembly configuration would be great in Onshape. That is true. We currently do part configurations. We do part studio configurations actually, which is gives you kind of like a pseudo assembly configurations, and we'll see how some of that works a little bit later. And the question there: are there plans to implement multi-body parts? Well, this is a big difference between the two products. SolidWorks was revolutionary back in 2003 when it introduced these multi-body parts, where this basically allows you to have one part built up from multiple bodies. And in Onshape, we do it as multi-part modeling rather than multi-body modeling. And again, we'll look at that in more detail. Okay, so legacy data. Now, SolidWorks as a product is over 22 years old. It shipped in late 95. So consequently, it's got thousands of companies around the world. It's been going for many years. It's been very successful, and it still is very successful. They're still shipping loads of licenses. You always get a good deal and a quarter, I'm sure. But each of those companies each have tens of thousands of files, if not millions, simply because they've had the product for so long, working on it daily. Especially if you've got multiple users, you're going to be generating lots of files. So the question we often get when people are considering moving from one system to another, and whether that be trying to do a wholesale switch from one to another, or to actually try and do work alongside. So you might use SolidWorks for some projects and Onshape for others. And again, simply from the benefits of Onshape, being able to easily share data with others, that's one reason why some people might run the two systems side by side. Okay, but there is a very common misconception. People think they should, once we've got our tens of thousands of SolidWorks files, we should just bulk upload everything into Onshape. And that is impractical for many reasons. And what we recommend is that you should only actually transfer the data that you need when you need it. First of all, once you import data into Onshape, it does have to translate it, and that does take time. You've got unlimited storage, so that's not the reason why I would say, don't transfer all of it. But it's whether the practicality of doing that and also the usability of it as well. So the suggestion, or what we recommend, is that you keep existing SolidWorks data in SolidWorks. If you've got 10 licenses of SolidWorks, there's no, and you tend to switch them off, there's no need to carry on paying your subscriptions. You can just keep your, one license of SolidWorks in the corner as your legacy CAD drawing database, if you like. And the idea is that if you have to refer to old data, you can still get it easily enough from your SolidWorks system, and really only transfer the data if you intend to reuse old geometry or old products, or you intend to reuse and modify it as well. So you might actually go in there and do a new revision for a part. Okay, and the other recommendation is that you would start new projects in Onshape. So rather than trying to, like I say, transfer everything, start off with new projects in Onshape and only transfer that data as and when you need it. Now, another recommendation is if you are considering Onshape, if you are perhaps in a pilot stage or you're on the professional trial, what many of our users or companies have done is to put one or two users on a project solely in Onshape. So take them off SolidWorks or whatever other CAD system and let them just use Onshape for a few weeks, a couple of months to see how they get on with it. And what you'll find is that there's going to be a few quirks at first as people get used to the differences. And there's always going to be, the odd feature that Onshape doesn't yet support. But what you'll find is that most people, when given the choice, do they want to stay on Onshape or would they prefer to go back to their old CAD system? 9 times out of 10, they want to stay on Onshape simply because of the convenience of being browser-based and not having to deal with files and PDM. And that is some of the biggest issues. Okay, so let's move on to a little bit more technical detail. So if you're importing legacy data, then one of the reasons why I also say is don't just bulk import everything is that Onshape imports SOLIDWORKS parts and assemblies only, so it doesn't support drawings. And if you do want to transfer drawings over, then the suggestion is that you could export them from SOLIDWORKS as PDF, so they would actually be a versioned drawing that you can refer to. You can insert that into your Onshape document, but there is no associativity between parts, assemblies, and drawings. Okay, will that come in the future? Who knows? But at this present, we only import parts and assemblies. And from that, those are from 1999, that's SOLIDWORKS 1999 onwards. So we'll pretty much bring in any legacy data, unless, of course, it's 20 plus years old. And the other thing you should consider as well is that, like any other CAD system, transferring data from one to the other, that no features are imported, only bodies. Okay, so it'll import solid bodies, surface bodies, wire bodies, which were things like curves and helical curves and that kind of thing. And for the most part, especially if you are just wanting to reuse existing SOLIDWORKS parts in an Onshape assembly, then for the most part that is okay. If you want to do detailed modifications, we'll show you some simple ways to do some modifications. But if you want to do some really, really detailed modifications, they may want to consider either doing it in SOLIDWORKS or remodeling the part in Onshape. And if you think if it's perhaps a configured part, there are thousands of them, it might be worth spending an hour or two just remodeling the parts. You can have SOLIDWORKS and Onshape open side by side. And because they are so similar in the way they work, you could literally just edit each feature in both CAD systems and just copy what you can see on screen. So, obviously I wouldn't recommend that if there's like a part with 200 or 300 features, but if it's something which is of relative simplicity and you think that you're going to be making lots of changes to it in the future, then it may well be worthwhile the effort, the time and effort to remodel a part in Onshape. The other thing that you should be aware of is that no mates are imported in assemblies, only relative positions. One of the reasons for that is that the way we do mates in Onshape is different. And again, from a legacy standpoint, if you are reusing an assembly, you could take them all together and fix them relative to each other. Or if you really need to be able to do some modifications and move them around, you can very easily add Onshape mates to bring them back together, and I'll show you how to do that as well. Okay, and the recommendation as well is that because we support parts and assemblies in SOLIDWORKS, so those are SLD PRT files and SLD ASM files, then the recommendation is to use the SOLIDWORKS Pack and Go feature. Now, if anybody is familiar with that, then it looks something like this. Okay, so the SOLIDWORKS Pack and Go feature can be found under the File menu. And what this will do is, so first of all, you would open the assembly that you want to transfer into Onshape, then go to the File menu in SOLIDWORKS and select Pack and Go. And what that will do, or the idea originally for this Pack and Go, was to make sure you don't lose references, because SOLIDWORKS only uses because SOLIDWORKS uses a file for every single part and assembly and subassembly, then it's very easy to lose references. A file might be off on a server somewhere which you're not aware of, and simply just copying the files out of a folder with Windows Explorer, chances are you might miss some files. So what this does in Pack and Go in SOLIDWORKS is to collect every single part reference and allow you to do a save as into another directory, or in this case, we're going to look at zip files. Okay. Yeah, I've got another couple of questions here before I move on, saying about fix and grouping in assemblies. Again, we'll cover that shortly, because we're going to cover some of the differences between the two systems. And so first of all, to create these systems, let me just oops. So there's some things that you should consider when using the Pack and Go feature. The first one is possibly include toolbox components. So you can see just where my mouse is here. Now, that, if you're using SOLIDWORKS Toolbox, that will create a copy of the correct configuration of the toolbox part and put it in the folder or zip file. It does mean, though, when you import that into Onshape, you're going to get lots of copies of the same fastener. So it's useful in the fact that you can determine, if you were trying to essentially convert an entire assembly to Onshape, it's useful in the fact that it lets you know, or you'll be able to see visually and by measurement, which correct fastener to use, and then you could use an Onshape standard fastener to replace it. But it does, just be aware, if you've got a lot of fasteners in your assembly, then it will create multiple copies of the same fastener. The other thing that we should consider is, by the default here, is save to folder, or actually, sorry, the save to zip file is the default. So you should select save to zip file and give that a name. Now, by default, if you use Pack and Go, the zip file name, and I don't know if you can see that on screen, is the same as the top level assembly. Okay, it does that by default, so that's nothing else to do on your end. Okay, but if you don't have access to SOLIDWORKS, or if you've got all your files in one folder and you just want to upload them into Onshape, then there's certainly a way around that. And that's way is just to create a zip file and name the zip file the same as the top level assembly. And that's just so that Onshape knows when it opens a zip file which assembly it should open, or which is the top level assembly. Because again, if you've got multiple sub-assemblies, it doesn't know which one is the top level unless you name the zip file. One last thing here is option here to flatten to a single folder. That is enabled by default, and I will keep that checked. Onshape will find in the zip file will find relative folders, but it's best to just flatten them all to one folder so everything can be found in the zip file easily. Okay, so let's take a look at this in more detail. Now, if you have let me just go to desktop. Okay, if you have SOLIDWORKS and you have a license to SOLIDWORKS that you have access to, then Pack and Go is definitely the option to use, because it does it all for you. However, if you don't, then you can do it manually, and you can do it very easily. So we have here a folder containing a bunch of parts, and you can see here I'm on Mac, so this might be a reason why I've not got access to SOLIDWORKS, because it only runs on Windows. But we'll see here that the top level assembly here is called comealong.sld.asm. Okay, so I don't want to keep this folder structure. I want to do the in the same sort of flatten the assembly structure. I will create a zip file in this same folder with all the parts. So easiest thing to do is to take all your parts, right click, on Mac it's called compress. I'm not sure, can't remember what it's called on Windows, but essentially create a zip file. And you'll see by default, certainly on Mac anyway, it creates it called archive. So all you need to do is just take the same name as the assembly, excluding the file extension, and just rename that zip file. So it's called comealong.zip. Okay, now there's a number of options that when you import this into Onshape, there are a number of options that you can use. Okay, so let's just go ahead and import those. You can either import files just under the Create button here, and when you import files, you could actually just randomly take a few of these parts here and import them into Onshape. Now, if you do it from the main document page like I'm doing here, that would actually create an Onshape document for each of those individual parts, which is fine if you're actually going to reuse those parts as a standalone piece that you're going to reuse in multiple assemblies. But and the other option is to create an empty Onshape document first, and then use the import option from the plus menu in the bottom left corner, and that will then take those part files and insert them into that one document. So it's a difference between, do you want to create multiple documents, or do you want to create one containing everything? Now, if we import just the zip file, then it's going to create one document. Just one thing I should probably point out at this point, if you are importing assemblies, you have to use the zip file or the pack and go. Importing this assembly on its own, even if you select all the parts, it will not understand the references between them. Onshape will simply think you are importing a bunch of separate files, and it will treat them as such. So having the zip file is a special way that Onshape understands the relationship between the assemblies and the parts. And this also works for Creo and CATIA and NX and Solid Edge, I think, where you can just put all the different assemblies and parts in one file and just rename the zip file. So it's not specific to Onshape. So selecting the comealong.zip file. Okay, now there's a couple of things that we should consider here. Now, first of all, if it's a SOLIDWORKS assembly, then you should always check this option here. So import models in the y-axis up coordinates. Now, if you take a look at Onshape, SOLIDWORKS, you can see that that the z-axis points outwards out of the screen, the y-axis points up, and the x-axis points to the right. In Onshape and every other CAD system, apart from Autodesk Inventor, the z-axis points up, and therefore the y-axis points into the screen and the x-axis points to the right. So if you don't check this option, then your models will come out at 90 degrees to where you expect them to be. If you forget to check that box, you can edit it afterwards, so don't worry too much. The next one which you should consider is to allow import of parts with faults. Now, because we are essentially reading the parasolid bodies out of the files, then there shouldn't be any faults. You'll typically use that option if you are perhaps importing a step file, definitely an IGES file, or any other file format that will basically make it less tolerant, give you more tolerance on the files. And if you don't have that checked, it will just come up with an error saying part has errors, not imported. Okay, so for the most part, we don't need to worry about that, especially if coming from SolidWorks. And then the important one here really depends on how you intend to reuse that assembly. If you intend to use it as an assembly and you need to keep the assembly structure, then leave the default option here. This will create an element tab inside the document, one for the top level assembly, one for each sub-assembly, and then it'll put all the parts in one single part studio, okay, which looks a bit funny at first and it can be quite difficult to navigate. So we'll take a look at that option in a moment. The next one is to do the same as the first, but rather than put an assembly all into one single document, it splits them out into multiple documents, and that might be useful if you have multiple people that you want them to work on these documents, and therefore they can work on individual documents if they wish. And the last option there, to flatten everything to a part studio, that basically creates one part studio and does not create any assemblies at all. And that is best for assemblies of standard parts, for example, that you might get from a supplier. If you get an electric motor, but your supplier sends you, rather than a simplified part file, they might send you the full assembly. You don't need it to appear as assembly, so you can flatten it to what we call a part studio. Okay, so let's just do the default. We'll look at the second one in a moment. Okay, and I select OK. Now that's going to upload that zip file, create a new document, and then, as we'll see from the notifications window here, it'll give us a running commentary of what it's doing. So at the moment it's saying it's imported. You can see the file, the document should say already exists, but it's in the process of importing. And because you can bulk upload data, you could have selected multiple zip files or multiple step files, for example, and Onshape would actually in turn upload each one and import it as well. Okay, so that's saying that it's translated successfully. So you can either click the link in the notification, or you can open the document in the normal way just by clicking the link here. Okay, now whenever you import any data, whether it's SOLIDWORKS or anything else, the actual file that the data originated in is stored in the tab, in a tab within the document. And the reason for that is that you then have a record of the data that you actually imported. You can version control that, you can download it, you can update it with some new data, or you can import it again, which we'll look in a moment. Okay, so that is the actual zip file itself. You can delete it if you never need to use it again. You can also delete it if you wish. But here we start off. The first tab will then be the high-level assembly. So you can see we have all the parts, and these are positioned in a relative position to each other. But as we scroll down the list here, you'll see there are 0 mate features. Okay, so that does mean that we can take these parts and drag them out in multiple locations. Okay, one way to overcome that, and I'll answer Alex's question while I'm doing that, is to especially if they don't want to sorry, excuse me, if they don't want these parts to move relative to each other, is that we can use this group option here, and box selects everything. That's going to group all those parts together so that they move relative to each other. Okay, and then as we move on, you can see everything moves relative to each other. There are no mates in between them. They're just individually grouped. Now, a common misconception of how things work or between sub-assemblies in Onshape and compared to SOLIDWORKS is that group is the best way to do it. If you let me go ahead and delete that group feature. If you go ahead and fix a part, okay, let's fix it. In fact, let's just take a bunch of parts there and fix everything. So everything is fixed. You can see in there. If I was to create a brand new assembly and insert that assembly in, which is that one, okay, you'll see that those are still free to move, and that does confuse people. I remember it confused me when I first tried it. But what's happening here is that fix in Onshape is not the same as fix in SOLIDWORKS. So fix in Onshape is basically just a temporary thing that you use in the assembly that you're working on. Okay, the rationale for that, behind that, I'm not quite sure, but that is how it works. So if you want to actually make things fixed relative to each other, then group is definitely the way forward. Okay, so that's one of the big differences there. Okay, so we have an assembly. In fact, if I click this button in the bottom left-hand corner here, we can see all the individual tabs that make up this assembly. So we have an assembly. In fact, let me just close that. We have a tab for each individual subassembly, and we can see there's perhaps some importing errors here because we have a part and some surfaces. There's a subassembly here, so it's actually maintaining the assembly structure, but it is the actual parts themselves are actually being stored in one individual part. And this will confuse a lot of people when they first see it, because it's imported. Essentially what Onshape has done here it's imported every single part on the origin. So there's no relative position here. Everything is done at the assembly level. Okay. What I'll do in a moment is to see a comparison here, or a different way to import it. But you can do a lot of things with imported data. For example, if I take this sheet metal part here and let's hide other parts. Okay, and we've got a bunch of surfaces there, so let's just ignore those for the moment. In fact, if I press Y on the keyboard, that's going to hide them. And you can see there's a curve there that's imported as well. So we have here what is a sheet metal part in SolidWorks, but when you bring it into Onshape, of course, it's just a single body. So what can you do with it? Okay, so for example, you can convert this to sheet metal models. So there's sheet metal capabilities inside Onshape. We do things slightly differently, but if you want to convert a sheet metal part into a non-shape sheet metal part, then the best way to do that is, first of all, is to measure what your thickness is. Okay, and it tells me down in the bottom corner there that says 1.587, or let's call it 1.6 gauge for argument's sake, and we'll convert this to sheet metal. Now, there are three options when you create a sheet metal model. One is convert, one is extrude, and one is thicken. Convert is like the convert to sheet metal feature in SolidWorks, except it does cover more cases. And this is really where you'd build a solid envelope to represent a case or a bracket, and then you would use convert to select which faces and which edges should be bent. Extrude is for taking sketches and giving them depth. But for this, thicken is the option that you want to use. So first of all, if I select one of these faces, you'll see it's added a thickness to that. Okay, and actually, what if I then select tangent propagation? It's going to go around the bends of each of the features and build the Onshape sheet metal model. Now you can see it's actually extruded it the wrong way, so I just need to flip that over. Okay, and it has actually created now a separate part on top of it, but it does give you the ability then to click on this tab over here, and you can see this is the sheet metal model flattened within Onshape. So if you wanted to do some changes to that, you could as well. So this is the Onshape sheet metal model, and if I wanted to move this slot over, for example, now we could either delete this slot, but you see in fact, let me just translate along an edge 5 millimeters, and I'm going to select the faces that I actually want to move. Okay, so you can modify existing geometry fairly easily within Onshape. So you can select features to move, features to delete, features to offset, and you can see here as I move this in the sheet metal model, it's going to update automatically as well in the flat pattern as well. So if you need to make those modifications, you can do, and it might just be something simple like you want to make this slot a little bit shorter. I should probably select a different reference. Okay, so you can then give that a new size and then do some kind of modification like that. You could also take some other geometry and perhaps delete it completely. So you can use the delete face feature here if you want to get rid of this hole completely. Actually, I'll get a better model for this. Let me just go back to the assembly. Okay, and let's go to this guy here. Now, what this will do is if you're trying to find something in a part studio and all the parts are on top of each other, the best thing to do is when you go to your top level assembly where you can actually see the part that you want to modify, if you right click on that part and select to switch to, so that's going to switch to the actual part studio, it will actually highlight or select the part that you already selected. So now if you right click and hide other parts, you're going to be able to see that part much easier. Okay, so again, you can do things, this now behaves just like it was a SolidWorks part. So you could add in a chamfer on the edges there, and of course that's modified there because it's because of the size of it. Okay, so you can add additional features, or you can use the delete face feature. If you wanted to get rid of this feature on here entirely, it's just a case of actually picking the geometry on there, and you'll see that removes it completely. Or again, if you use the move face feature like we saw previously, if you want to move that up the hook, then you could do that as well. So in summary, for moving data from one system to another, whether it be SOLIDWORKS or any other CAD system, is you can take the data in, you can reuse it in different assemblies. You can also create standard part libraries and insert those into different Onshape documents very easily. But there's two ways you should think about if you need to modify it. You can either, if it's an existing project, which there's been an issue and you need to make a change, it's probably better to do that in SOLIDWORKS if it's a quick change, because then of course all your drawings are going to update. But if it's something that you're going to bring forward, you're going to reuse in future projects, you can either just insert it as a what we'll call a dumb solid here. You can make modifications like we've seen with move face and delete face and all these types of options. So these are all the direct editing options within Onshape. Or if it's something which you intend to reuse regularly and you know that you're going to make lots of changes, then again it might be worth taking the time to remodel it from scratch. If it's something that needs to change quite a lot. Okay, let's take a look at first of all setting up your account. When you move over to Onshape, there is you can select preferences. Okay, so in preferences under manage account in your name in the top right corner, you'll see there are some settings that you can set which make it the transition from one system to another a lot easier. By default, in Onshape, if you want to rotate, it's the right-hand mouse button. If you want to pan, it's the middle mouse button, and zoom is the scroll wheel. However, if you want to use SOLIDWORKS or any other system default, then you'll see that now rotate is the middle mouse button. You can use pan with control middle mouse button or middle mouse button drag. And then you've got the scroll wheel again for zoom. And by default, the reverse scroll wheel zoom direction again matches how SOLIDWORKS is set up. You can change any of these options and save your view manipulation settings. So especially useful if you first moving on to Onshape, or if you're using both systems side by side, you're jumping from one to the other. Of course, it can get confusing with the mouse and the models flying around on the screen. So worth changing. Second thing on here is shortcut toolbars. Anyone who uses SOLIDWORKS hopefully will be familiar with the S key. That brings up a toolbar shortcut where your mouse cursor is. It is the same on Onshape. You press the S key, it's going to appear. And you can specify either for sketch, for modeling, for assemblies, or for drawings. You can configure this toolbar just by selecting which options you want to add. It's going to modify that toolbar, and then every time you press the S key, whilst you're in a part, assembly, drawing, or a sketch, then that toolbar will show up next to your mouse. So again, just really for power users want to get there quick to the command, you can set those up directly within the Onshape user interface, make it very familiar to your working practices in SOLIDWORKS. You can also you'll find, especially in what we call a part studio, is that every single command that is available is on the screen there. And to be fair, I recommend not to touch that, because in case you, or certainly until you are a seasoned user, because there might be things that you never use, some like thicken and enclose, which are surface capabilities. So you can actually right click and customize a toolbar and take stuff out if you wanted to. So move stuff around and this kind of thing. But again, that is really a power user type thing, and it's there if you need it. Okay, last thing I would talk about is really the differences between parts and assemblies, and also how we share data as well. So we've already taken a little bit look at modifying parts with the direct editing tools. I've also looked at fix and group in assemblies. But what I want to take a look at just briefly is the difference between how we model parts in Onshape and how we create assemblies in Onshape. If anybody used Onshape before, you might be familiar with this, so I'll keep this brief. But the idea here is that when we create parts in Onshape, we don't do it as one part per file or one part per tab, if you like. We create parts which are related to each other together. And the idea is that you're not creating things like in-place mates in SOLIDWORKS, which are easily broken. If things move, things are going to break easily. If you've got relationships between parts in an assembly, or if a part file goes missing in SOLIDWORKS, things can blow up very easily. We've changed that in Onshape and doing it as a part studio to avoid those types of scenarios. When we come to extrude, this is one sketch, which is essentially a layout. You can select which profiles or which areas of a sketch that you're going to extrude. So this is very similar to contour select inside SOLIDWORKS. Okay, so if you ever use contour select in SOLIDWORKS, then you'll know how this works. Okay, so there's my first extrude. Okay, now when I create a second extrude, okay, and I pick these features, and let me just change these again and reverse that around the other side. Okay, you'll see by default that because these two features intersect, then Onshape puts them as an add operation. Okay, but really, in fact, there are two new parts, so select new in this case. So this is really like now a multi-body part, and I'm checking the merge option inside SOLIDWORKS if you've ever used that. Now, the main difference here now is that if this is not one part with two bodies, it's actually two individual parts. These individual parts can have different materials. They can have different part numbers. You can put a single part through a release procedure. So there is lots of things that you can do with these parts. You can insert one part into an assembly, whereas again with multi-body parts in SOLIDWORKS, they are treated as one individual part. Okay, and then you can start to do other things like, okay, well, let's extrude some other features. Let's extrude some of these, and we'll do that, and we'll do up to face of a plane over here. That's going to be a new part, and let's take oops, sorry, picking the wrong thing. What take these and these features, so you can build lots of parts together. And the beauty of this is that once you've actually put the parts together, you can do things like perhaps do a Boolean operation. So want to subtract this shape, this blue shape, from these two pins. That will then automatically give you, and again, if I hide this will automatically give you the step in the pins. So this is just an easier, quick way to put in like relationships between parts, and we do this, like say, in this thing called a part studio. So if I ever to change that, say let's edit the sketch, and clicking this final button will basically regenerate the part studio for me, so you can see it update in real time. But as I move this, you can see that the layout now drives all the individual parts. So you can do any kind of top-level, top-down design in a single part studio, and then put that together in an assembly. So the question might be then, okay, why would you use an assembly? And in fact, let me just do one more extrude. Let's take that and new part, and we'll do that up to face, mid-plane. Okay, so that's creating a new pin. And again, you can see, you can do like a second direction here, and we'll do up to face, up to this part here. So that's created a pin for me there. All right, so why would you use an assembly? Well, the reason why we use an assembly is to capture a number of things. If there's motion, we'll capture that. Bill of materials are the two big ones that you use an assembly for. But like I say, if this was a part which was provided by a supplier and there was no motion involved, it was just an electric motor. Obviously, the shaft revolves, but you don't really need to see that. you don't need to create an assembly. You can create this as a multi-part part studio. So then when you do create a brand new assembly, you can insert them all together. Okay, so you can either, so you see in this part studio here, you've got the individual parts, so you can use those in any assembly. Or if you click on the top level there, it's going to insert those all together. Okay, now they are in their relative positions, how they appeared in the part studio, but you'll see that they are free to move because they are parts in their own right. Okay, and in fact, let me get rid. I'm going to delete that one. Okay, now how we do assemblies is slightly different. We'll see that rather than creating insert mates and align and all those kind of things, we create mates using what we call higher level mates. So they're things like fastened and revolved and slider. So we're defining the degrees of freedom for each part. So we might want to say, we'll take this part here and I'll fix it. Okay, again, if you're going to use it in a top level assembly, group is the best way. But in reality here, the fix then will give you just a localized part that you know is not going to move. Okay, then if you're going to revolve something, you can now see we've got these things that we call mate connectors. As we hover over geometry on the part, you'll see these little, what are essentially coordinate systems. They appear at vertices, they appear at center of holes, or you can create your own. So if you want to say, I want that hole there to be at the center of the end of that pin, then that's going to create that reference there. And you can add in offset. So if you want to position that offset, or you can add in limits. But we've selected revolute, so that essentially then give you this kind of motion. Likewise, you could say, okay, well actually we'll do a revolute between there, and this time we'll pick the center of that part, or that hole I should say, and you can see that now moves relative to that. Okay, so very quickly with, and you would see from some of these, we could have grouped these, but also you might just want to fasten these. So we'll say we'll fasten from the edge of that to the edge of there. So that's now going to move with that, and let's fasten that to there. Now it's quite, when SOLIDWORKS users come into Onshape, they're quite easy to spot because we see a lot of planar mates as people try to add 3 or 4 mates to put things together. But please bear in mind that these are driven from one single mate. So as you position these, you can see these now move relative based on the types of mates that you've added. Okay, and finally, the last thing I would like to talk about is how you actually go ahead and share data with somebody. Now, when you share data with somebody, let me take myself out of there for a moment, is that you can do this without having to export anything. Now, if you're wanting to share a document with a supplier or somebody else within your company, you can specify different types of access permissions. So, for example, if I email to put my own email address in there, then I can specify whether that person can edit or whether they can view. So perhaps if that person is a supplier, then you might want to give them view and comment permissions. So when you share that person then gets an email and they click on the link. If they have Onshape account, it will open in the browser. If they don't, it will still open in the browser, and they can manipulate the model as we've seen. They can view it, they can rotate it, they can measure it, they can take a look at some of the feature details. But the idea here is that because data has never actually left our server and they're viewing it through a browser, they've not had to install anything. They've not had to, you don't have to worry about the wrong versions of files because it's the document that you've shared with them, so it's always going to be up to date. And then also, if you want to give them permissions to edit the document, perhaps they are an approved supplier now, you want them to be able to edit, and in order to, or I should say export, perhaps they want to export it to do CAM, for example. They could export it as a step file for their CAM system. You probably don't want to allow them to let them copy it, but if you do want to let them edit it, you can then say, okay, well, let's turn off copy, let's say export. So now if they have an Onshape standard or professional account, they will be able to modify that data with you. Okay. and then simply update that. And the beauty of this is that if you decide that that person should no longer have access to your data, simply clicking the X next to their name will remove their access immediately. So even if they've got the model open on the screen and they're viewing it, it will kick them out immediately. So from an intellectual property standpoint, it's a very powerful and very secure way of keeping your data safe. Okay, so that is the main bulk of the presentation. So I will leave it open for a couple of minutes with questions, but in essence, we're taking a look at how you can transfer data over, why you should transfer it over, and when. Best practices for keeping your data in SOLIDWORKS for when it's needed, for modifying old data that doesn't need to be brought forward, and transferring it into Onshape when you do need to reuse it. Setting up the UI, and also really just taking an overview look at the differences between how we model parts and how we model assemblies in Onshape. Of course, what I've not looked at here is drawings. Drawings work in a very similar fashion to how you use them in SOLIDWORKS, but obviously there is no importing capabilities of SOLIDWORKS drawings at this time. So that's it from me. I'll stick around for a few minutes to answer any questions. I hope that you found this useful, and have a nice day.